So in this section for Module 1, we'll call it Homework 2, we're going to be looking at something called inequalities, and they are kind of what they sound like. They're when things are not quite equal. And we'll I think it's best to explain this with some examples. So let's kind of go down here to example 1, and I'll fill in the rest of this chart at the top of the page for you in just a few minutes. But first, in example 1, it says they want us to express each individual in something called set builder notation and then graph it on a number line. Now, I've given you a line here that we're going to use as a number line. And set builder notation, I just want you to note that here's an example of it just above our first problem. It starts with what we call a curvy bracket, and it has a curvy bracket, and it says, we read it like this. We say the set of x such that, that's a straight bar up and down, such that x is greater than whatever, the number 0, okay? So this is an inequality because it's not equal to 0, it's not equal to a certain number. It creates what we call an interval. Now an interval, here's the word that I'm saying right here, is an interval is something that includes a bunch of numbers, a range of numbers, not just one number. So we're going to work with inequalities and see how solving those and how expressing those, and we'll end up expressing them in 3 different formats. Set builder notation is just one of those. First example, they want us to take this interval that's already solved for us, really, and it's expressed in set builder notation, and they want us to graph it on a number line. Now I want you to note that this one is really kind of a complicated one. It has x being greater than -3 and x being less than or equal to positive 4. And I could write it as 2 different statements. I could say one of those statements is x is greater than or equal to a -3. Now, why did I turn around my inequality? Well, look, I didn't. I just switched everything around. X, the big part of my sign here, my inequality sign, is pointed toward x. It still is. And the equal sign, of course, doesn't change no matter what you do. So I've got, that's my first condition. And then I would say, and my second condition for this one is that x is less than or equal to 4. So both of those conditions have to be true for a number to be included in this set that we've got. So let's kind of map it out. We take a number line and we say, okay, I always put 0 on my number line. There's 0. It sort of centers us here. And I'm going to map out where my number line has limits. Now, this number line, as you understand, goes to infinity on both sides. On the right side, it would be reaching what we call positive infinity. There's the symbol for it. On the left side, it would reach negative infinity. Those are not really numbers. They're theoretical. It means that it goes on and on forever in a negative direction. It goes on and on forever in a positive direction. So it's not really a number it's reaching. It's just a theoretical concept. It goes on forever, and you probably understand that. Now let's put in the other 2 numbers that are in our inequality. They're the limits of the set if you want to, and one of them's over here. It's -3. We really don't care where we put it as long as we get it on the right side of 0, okay? Next one, I'm going to put it over here. It's a positive 4. Now, where are my numbers that fulfill this set? Where are my numbers that are included in the set? Well, x has to be greater than this -3 or equal. We'll get to that in a minute. And it stops at positive 4. So that includes everything. Now, how do I tell it, though, that this little equal sign is there? This little equal sign says x could be equal to a -3. And this line simply doesn't tell me that. I mean, x could have stopped just before -3, but it didn't. So we use what we call a square bracket. I've sometimes called them hard brackets because they look like that to me, but it's really a box bracket or a square bracket. And that bracket shows us that -3 is included in the set. Over here, we're going to do the same thing for the positive 4. Positive 4 is included in the set. So we have covered it in what we call our graphing notation here. We've got it in set builder notation. And there's one more notation that we're going to work on in a little bit, but let's just do this one for the time being. I want to go down to the next problem before I fill in the top of the page, and let's do this one. This one says the set of x such that x is less than or equal to 4 and x is greater than a -3. So I could put that in 2 different statements if I wanted to. I'm going to turn this first one around and say x is less than or equal to 4 and x is greater than a -3, right? Now, that's kind of tricky because it's not easy to graph it that way. I mean, I would have normally put the -4 first. I'm sorry, the -3 first and the 4 second. I would have written it a different way. And you could think about it that way too. You can just turn the thing around. You can move these numbers so that the 3 is first. And remember to just point your inequality sign toward the number that it's pointed toward. It was pointed toward -3. It's still pointed toward -3. We're going to put x in the middle. And we're going to put 4 over here. Well, this inequality sign this time is pointed toward x. And remember, it has an equal. This is easier to graph. It's easier to graph because it starts with the smallest number and goes to the larger number. Let's go again with our number line. It goes to -infinity. On the left, it goes to positive infinity. On the right, you can think of it as arrows if you want to. It goes on and on forever. And let's put in the two important numbers, our -3 and our +4. And then let's say, okay, x is everything between those two numbers. Look at it. It's less than or equal to 4, so it's going to go in this direction. See, it points in the same direction as that arrow, doesn't it? It's going to go in this direction, and it's going to stop at -3. X is greater than -3. The only difference in our first example and our second one here is that one of these inequality signs does not have equal, right? So that's going to change our bracket. That's all it's going to change. Down here where we have -3, this says that x could be everything greater than -3, and it cannot include -3. Well, how do we show that? We do it with the parentheses bracket, or what we call the round bracket. You can think of it either way. So this round bracket says go all the way to -3, but don't include -3. What do we use over here with +4, though? Well, the +4 has an equal sign associated with it, doesn't it? So we're going to say square bracket for that one. Now let's go back up to the top of the page because I gave you these examples just so I could fill in this chart for you. And we're going to look at some of these brackets and write it down so that you'll have something to remember it by. First of all, these symbols. I want the symbol less than and the symbol greater than. It's really okay if you just remember that the small pointed end always points toward the smaller number. The big end of the bracket or the symbol always points toward the larger number. And so we say less than, we say greater than. What notation we use when we're doing this is we use rounded brackets, okay? I'm going to put a comma in there because there's always numbers between them. But we've got rounded brackets. If you want to think of those, you can think of those as parentheses. Or you can think of them as round brackets. All right, next, what do we use when we have a symbol that has an equal sign associated with it? It's either less than or equal, or it could be greater than or equal. In other words, either condition would make it true, okay? If it was greater than or if it was equal to the number. In other words, those endpoints are included in the set. So we use the square brackets. These are called square brackets. Or you could call them box brackets. All right? Now, what about parentheses? What do you do with those with an interval continues indefinitely? What do you do if it goes all the way and never stops? Okay, so we've got something called negative infinity on the left. We've got something called positive infinity on the right. And what kind of bracket do we use if we hit that situation? Well, infinities always use the round brackets because it will never actually be equal to infinity. You can think of it as it's never going to reach it, it's never going to be equal to it, therefore it would never use the square bracket. We use a round one for that one. Let's take a look at an example of that. Our last example on the page is a problem just like this. Let's see if I can get it on our screen here. And basically this one is the set of x, the set of x such that x is less than 2. All right, so I'm going to look at it with a number line, and I'm going to say, okay, I'm going to put 0 on there because I always put 0 on there. And 2 is to the right, of course. Infinity, positive infinity, is over here. Negative infinity is over here somewhere. And I want x to be less than 2. Well, I know x starts at 2. Which direction does it go? you can always, if your variable, your x, is listed first in an inequality, you can always use the direction of the arrow, the direction of the inequality, to tell you which direction to go. And this is what I'm doing. It goes forever and ever, doesn't it? So I can put an arrow anywhere I want to. Now, which bracket do I use over here? I would say that that is going to be a round bracket because it is not equal to the 2. So where does the round bracket with the inequality sign come in? Well, we're going to add that in just a minute, okay? I'm going to finish this next one, and then we're going to come back and do something else, some other notation with these, okay? We got set builder notation, and then we'll have another notation to add. All right, this next one. The set of x such that x is greater than or equal to the -1. Well, here we go. Let's just go ahead and say here's 0, and over here somewhere is -1. This is negative infinity, and this over here is positive infinity, and I need to be greater than -1, right, or equal, but this is the direction I'm going in. I'm following my bracket because my variable x is listed first. I can do that. Which bracket do I use for -1? Well, it does have an equal sign, so I'll use a square bracket. So that's our set builder notation for these intervals. Let's go on to the next page, and we're going to get a chance to work in some other notations as well, okay? So, let me see if I can focus this in for you guys real quick. So, we're solving linear equations. And I put some notes up here for you to remind you that you do it very much like you would do any other equation. You clear parentheses first, you clear fractions or decimals, combine like terms, add and subtract the variables, add and subtract to get the constants on one side. You want to get the variables on one side, the constants on another, and then you can multiply or divide as needed. But remember, the only thing that is different is right here. If you have to multiply or divide both sides of an inequality by a negative number, then you switch the direction of the inequality. That's the only trick, only extra step. Otherwise, we're solving it just like we would solve any other equation. We're going to use a notation for representing the intervals as pairs and numbers, and I'm sorry this didn't print well on mine. I hope it's better in your book. The numbers are the endpoints of the interval, and we'll look at endpoints in an interval notation, and we'll look at them from the smallest on the left to the largest, and I'm going to give you an example that you should be able to follow. So here's our exercise. We're going to use the null sign. Other than the null sign, we're going to use interval notation this time to express solutions and graph each solution on a number line, which I put down. So instead of set builder notation, this one we're going to work on is interval notation, okay? Now, look at my equation, though. It is not nearly as simple as the ones I was giving you on the last page. In fact, it's fairly complicated. I've got to do some distributing multiplication, and then I'm going to have to get the variables on one side and the constants on the other side, and I'm going to have to solve for x. So I'm going to do that just like I do any other equation. The only thing I have to keep in mind is this last part. If I end up multiplying or dividing both sides by a negative, I have to turn this inequality around. All right, so let's do it. 7 times x would give me a 7x. I'm going to come over here for more room. And then I'd say 7 times -4 is going to be -28. And I'm going to put my inequality down just like it was because it hadn't changed yet. And then I say 4 times 2x, well, that would be 8x. And then 4 times -1 is -4. Now, I need to get these x's on the same side. The only thing is, remember me telling you that I wanted the x's when we are looking at inequalities, we really want that variable x to be on the left. Well, okay, so I'm going to have to get them all to the left where there's more of them over here. And when I subtract 8x, I'm going to end up with negative. You could do it another way, but this is easier as far as the graphing we've got to do. So I say 7x minus 8x, that's going to give me a negative x, isn't it? Minus 28. I'm going to keep this because all I did was subtract 8x. I didn't multiply or divide by negative, not yet. And I have over here my -4 is all that's left. Now I'm going to do some addition. I need to get rid of a negative 28, so I will add 28 over here. That'll make it go away. And I'll add 28 over here, which is really like saying 28 minus 4, isn't it? So I'm going to come up with 24. And I'm going to end up with, my inequality sign hadn't changed yet. And I've got a negative x less than 24, but I can't graph negative x. So it's really simple. What do? Well, I divide both sides by negative 1. Let's say divide. I could multiply, but let's just call it division. Now, this turns into a negative divided by negative, which is a positive 1. And this turns into negative 24. But this is where you have to really pay attention and be careful. I'm going to draw a circle around it because I have to switch this. Why? Because I divided both sides of my inequality by negative. It turns the inequality around. Now remember, if it had been less than or equal, then I wouldn't do anything to equal. I'd just keep it, but I would flip the inequality sign, okay? So now I can graph it. I've got x over here on the left. I need that in order to graph it. I'm going to say, okay, I've got a 0 on my number line. I've got a negative 24. I've got a negative infinity over here. I've got a positive infinity over here. And I'm going to say everything x is greater than. In other words, point it toward, I'm in the direction my inequality, my graph points in the way of the arrow. And the only reason that works is because I have x over here on the left. If x had been on the right, it wouldn't be true, okay? Now, what bracket do I use? Well, I'm going to use the rounded bracket because it's not equal to negative 24 ever. It's got to be greater than negative 24. Now, let's look at what interval notation tells us to do. Interval notation is really easy once we have this graphed. It says, what is the smallest number that x can be? Well, our limit down here is negative 24. And then we put a comma and say, what's the biggest x could ever reach? Well, it doesn't. If it goes to its largest, it goes all the way to infinity. Okay, we've got the two numbers. We got the smaller and the larger, the smallest and the largest. Let's put the brackets. Well, we know that it can never be 24, negative 24, because it doesn't have an equal. So we'll put the rounded bracket. And we know that infinity always has a rounded bracket. This is our interval notation. So you've got three things or ways that you know now. You know how to do it with set builder notation. You know how to represent it on a graph, and you know how to represent it with interval notation, and you are responsible for all three of those when we test on this material. Let's do another one. Let's do one that has fractions in it. This last example on this page, it's a little bit trickier to solve. You just have to keep in mind this whole complicated term here is one fraction. It is therefore one term. I'm going to go ahead and put my numerator in parentheses. I'm going to do the same with that second fraction just because I don't want to forget that it's just one term. 1, 2, 3 terms in my equation is what I've got, or my inequality. Now, what are my denominators? Because I got fractions. I have two fractions. So my least common denominator for the three fractions, or the two fractions, it would be a multiple of 8. Will 8 work? Well, yeah, 2 will divide evenly into 8. So I'm going to use 8 as my least common denominator. And I'm going to do the same thing I've always done with clearing the fractions. I'm going to multiply each term by the least common denominator. So over here I'm going to say times 8 over 1. And here I'm going to say times 8 over 1. And here I'll just say times 8 because it's a whole number, right? All right, so cross reduce. 2 will divide into 8. 2 will divide into 2 one time. It'll just be a 1. 8 divided by 2 is 4. I'm done with that one. Cross reducing. Let's just finish the cross reducing here. 8 will divide into both of those. They turn into 1s. Now, I don't have to do anything on that side yet. Let's do the multiplication. I've got all 1s in my denominators. Therefore, I've gotten rid of the fractions. I have all whole numbers. I can just distribute this multiplication, can't I? I can say 4 times negative x is a negative 4x. I can say, I'll draw the arrow, 4 times a positive 2 is a positive 8. Very good. Now here, I've just got a 1 out here, but I must distribute the negative. So in other words, I'm multiplying negative 1 times 7. I get negative 7. Negative 1 times negative 7x, I get positive 7x. What's next? Well, bring down my inequality. and say negative 7 times 8 is negative 56. Good so far. Now let's just combine these like terms over here. I've got my variables. I have a negative 4x, and I have a positive 7x. Hang on just a second. Let me make sure I've got my screen working like it needs to be. There we go. I think that's right. So I've got my negative 4x, my positive 7x. When I combine them, I end up with a positive 3x. And then I've got these constants, or these numeric terms. 8 minus 7, well, that's just 1, plus positive 1. So bring down that same inequality. And now I can say, okay, let's get rid of this 1. It's over here messing us up. I'll subtract 1. And I end up with 3x less than negative 57. Remember, when you add terms and they have the same sign, we add them together and keep the sign, even if it's negative, right? Next, I'm going to divide by a positive 3 because that's the coefficient of the variable term, isn't it? So I end up with x, and I'm going to say it's less than, it's going to be a negative number, and I have to kind of, okay, what is 57 divided by 3? Okay, I should know that one. Maybe I don't. So 57 divided by 3, just to be careful. Okay, it's 19. Negative 19. Now, x is less than negative 19. Now, anywhere in this thing, did I multiply or divide both sides by a negative number? I didn't. I subtracted from both sides, but I didn't multiply by a negative. And there's a big difference in that. So I didn't have to switch my inequality for this one. Let's just put this on a number line. I'm going to have to come over here and say this is 0 and this is negative 19, okay? Because I've kind of run out of room. Over here, I've got my negative infinity, of course, and over here I've got my positive infinity. And I'm going to say start at negative 19 and go to the left. Small arrow, but you get the picture. Does my answer include the negative 19? Well, no, there's no equal, so I use a round bracket. And now I need to write it in interval notation. So what's the smallest number? I'll put a comma. I have the smallest number over here, largest number over here. Well, the smallest this thing will ever reach would be negative infinity. The largest it'll ever get to is a negative 19. And what kind of brackets? Well, infinities always use round. This one uses a round bracket because the inequality does not have an equal. So we've got our interval notation here. It's not really hard. It's just that one extra rule for solving inequalities that you have to remember. All right, let's take the next page. Now this is what we call a little bit more complicated. It's called a compound inequality. Now, it contains two inequality symbols in it. See, there's one over here and there's one over here. Remember, we looked at this sort of when we were looking at them at the first. There were, instead of two sides to an equation, this thing really has three sides because I've got two inequality signs. I could say this is side 1, this is side 2, this is side 3. This is a really complicated fraction, but I'm going to treat it as one term. I'm going to stick that in parentheses just to remind myself. And I'm going to set out to clear the fractions. Same thing I always do. I only have one fraction. So what's the least common denominator? Well, that makes it easy, doesn't it? The least common denominator for this one is going to be 4, right? So what do I do now? Well, next I say multiply each term in the equation by that least common denominator. So over here I'm going to say times 4. In the middle, I'm going to say times 4 over 1 because I'm going to cross reduce those. And over here on the right, I'm going to say times 4. Let's go ahead and cross reduce. These both divide by 4, so they end up with 1s. Well, that's easy. 4 times negative 8 is a negative 32. And bringing down my inequality sign, this becomes just a positive 1. 1's everywhere. All I have to do, I can get rid of those parentheses now because I don't need them. I didn't have to distribute anything. And I can say 3 times 4. Next, find your variable. It should be in the middle. Your variable term has to be isolated. Well, it's not. It's got plus 1 with it. Well, let's get rid of it. We're going to subtract it. But if we do something to an inequality, a three-sided, a compound inequality, we've got to do it to all three sides. So I'm going to come over here and subtract 1. And I'm going to come over here and subtract 1. Negative 32 minus 1 becomes negative 33. Bring down my inequality. I get rid of this 1 in the center of it, It just has a negative 3x now. Bring down my inequality, and I say 12 minus 1 is 11. Okay, look at your variable term again. And what do I have to do? Well, I've got to get rid of this negative 3 that's multiplied, so I'm going to have to do the opposite of multiplication and division. I divide by negative 3. All three sides have to be divided by negative 3. Okay, that changes things. That means, and I'm going to draw a little arrow here just to remind myself that I'm dividing by negative, therefore the inequality signs are going to have to flip. I'll say negative 33 divided by 3 becomes positive 11, and I flip my inequality sign. Of course, equal doesn't flip. I divide these two, and I get a positive x. I flip my other inequality sign around, and I say this is really a negative number. A positive divided by negative, I can just say that it's going to be a fraction because it doesn't reduce. I'll leave it as a fraction. It's negative 11 thirds. Now, how do I graph this? Well, remember me telling you that it's so much easier to graph if your smallest number is listed first. This time, the 11 is much bigger than a negative 11 thirds, isn't it? So let's turn this thing around. Let's go a negative 11 thirds, and x in the middle, and 11 over here. And let's just say, between x and negative 11 thirds, the inequality was pointing toward negative 11 thirds. Well, we keep it pointing toward it, right? In other words, we turn it around. We turn it around and put it here. We're going to do the same thing for this one. We're going to point it toward the x, aren't we? Now, both of them still had equal. I go back to the top to make sure that equal is right, and I haven't gotten off track somewhere. And I'm really ready to graph it. I'm going to put a 0 here. I'm going to put an 11 here. And I'm going to go down here and put negative 11 thirds. Really, fractions are no big deal to graph because you can make up wherever you want to put them. There's negative infinity. Here's positive infinity. And I know that x is everything between the two, isn't it? X is greater than, see that big part of my inequality is toward the x, so x is greater than that of negative 11 thirds, and it's less than 11, so I'm going to go all the way to that, and I'm going to use square brackets for each because of the equals. Now let's do interval notation. Well, interval notation says, what's the smallest it could ever be? Well, it's closed off with negative 11 thirds and positive 11. And we use square brackets to show that it could be equal to either of those numbers. So I hope that helps you some with interval notation. I know for most of you this is just a refresher. You're being reminded how this works. We're going to go on now into something that you may also be needing a refresher on, which is really graphing. And we're talking here about the Cartesian coordinate system. And if you remember that system at all, you remember that it has 4 quadrants or 4 areas on it. It's split by the y-axis and the x-axis. So instead of like one number line, we got 2. Now the y-axis goes up and down, and positive numbers go up, negative numbers go down. The x-axis is more like the number line you're used to working with, positive to the right, negative to the left, and they cross in the middle at a point or a coordinate that we call 0, 0, or the origin. So right there in the center is usually where we start graphing. What you have to remember is each of these quadrants is unique. We start over here with the top right quadrant. It's named Roman numeral 1. It's the first quadrant, or quadrant 1. And then we're going to go counterclockwise, numbering them. So this would be quadrant 2, and this would be quadrant 3, and finally we get quadrant 4. Now, what's unique about these is that if I have a point that's inside quadrant 1, it's going to have a positive x value. It's also going to have a positive y value. So when I look at that point, I think of it as being positive x, positive y. Now, every time I put a point down, I have the x coordinate and the y coordinate inside parentheses, okay, to remind you of that. So it is positive x, positive y. If I have a point with that, I know it's in quadrant 1. What about quadrant 2? Well, it would have to have, x value would have to be negative for it to get over here. And the y value still has to be positive because it's up on the top half of my graph. Quadrant 3, well, the x value has to be negative for it to be in quadrant 3, and the y value also has to be negative. And quadrant 4 has a positive value for x and a negative value for y. So you see, even just by looking at a point, I know which quadrant it's in if I think about it. For example, let's look at this one. What quadrant is point 3, negative 2 in? Well, it would be go positive 3. We always start with this is x, right? And this is y. I start at the origin and I count 1, 2, 3. And now I'm going to go negative 2. Well, that's in the y direction, so I'm going down negative 2. And this is point 3, negative 2. What quadrant is that in? Well, it's in quadrant number 4, isn't it? It is in, and you could tell, it has positive x, negative y. All of those have to be in quadrant 4. What about 0, 3? Well, in the x direction, I don't go anywhere. I'm going to stay right here. But I do move in a y, on the y-axis, I'm going to move up to a 3. That is 0.03. Now, this is what we call a Y-intercept, okay? A Y-intercept means it has crossed the y-axis at the point 0,3. One thing about y-intercepts that you can keep in mind is x will always equal 0 for a y-intercept. The only number that you'll have will be the y-coordinate, okay? Because to be on the y-axis, x has to be 0. Next, let's look at this one. It's negative 4, 1. Well, let's go. X direction, negative 4 over here. Positive 1 for y. So I go up. I'll say that's negative 4, 1. And where is it? Well, it's in quadrant 2. Does it fit our rule of having a negative, positive? Yeah, negative 4, positive 1. Another one is going to be a negative 1, 0. And that, in the x direction, the x we go over 1, but we don't move anywhere for y, so it's right here. That's the opposite of what we did a minute ago. This is negative 1, 0, isn't it? You see how those two are opposites? What do you think we call this one? You're right, it's the x-intercept. It is where it crosses the x-axis. What do we know about the x-intercept? Y is always equal to 0. Memorize that, okay? X-intercept, y is equal to 0. Y-intercept, x is equal to 0. It'll help you graphing. All right, what about this one? I've got a negative 2.5 and negative 3. Well, it's not too hard to graph negative 2.5. You just go negative direction 2 1/2. I can go halfway. And then I'm going to go down 3, right about here. That would be the point. Negative 2 1/2, negative 3. And where is it? Well, it's in quadrant 3. Why do I know? Well, look, it has negative, negative, doesn't it? And that's always quadrant 3. Okay, what about 3.5, which is really 3.5, right? If I go 3.5, I'm about here. And then I go 4.5, I got to go positive, so I got to go up. 4.5, I'm about here, right? So I've got 3.5, 4.5, positive, positive. It's going to be in the first quadrant. And we check it. Yep, positive, positive is always the first quadrant. So I hope that reminds you of how to graph points on the Cartesian coordinate system, because we're going to need to do this. We're going to be using them as we start to graph linear equations or lines, okay? Let's go to the next page and see what we can do with that. Now, what exactly is our definition of a linear equation? Okay, a linear equation really has 2 points on it that any 2 points really give us a straight line, right? A linear equation is something that we will have a straight line, and a standard form of a linear equation is this one. We have a number times x plus a number times y is going to equal a third number. So we'll have an x variable and we'll have a y variable, but we won't have anything that I want you to think of as unusual mathematical terms. We won't have any absolute value. We won't have any squared things. We won't have anything like that. So we just have to have x and y, or x or y, and a number maybe, and that's going to give us a linear equation. There's all different variations on this that you'll see as you go through the work on this one, okay? So first one, as an example, we're going to say, is this a linear equation or not? Well, a linear equation can have an x and it can have a y variable, it can have a numeric variable, but it can't have anything squared or absolute value. Is it? And that makes it a straight line. And this one fits that criteria. So the standard form of it is usually ax plus be y. In other words, if you were standard form of this, when you probably turn it around, it would say negative 3x plus y is equal to 2. I mean, you can tell that's the exact same equation, just rewritten the standard form of it. But what they're asking us is it linear? And this one, yep, it's linear. It is a straight line. Okay, it doesn't have it does have either an x or a y variable. Doesn't have to have both. This one does, but it can't have any other unusual symbols in it, mathematical functions like squares or anything like that. Okay, and it's hard to explain that. I'll show you some examples. All right, first I'm going to graph it by point plotting. I'm going to figure out what points fit on this line. Now, you know, any straight line, if I find 2 points, I draw a line, but with those 2 points, I've got a straight line, right? And these linear equations continue on indefinitely, so I never really have an end. All I have to do is find 2 points. It's a good idea, though, to find 3 points. And if all 3 of those points are in a straight line, then you're pretty good with your line. Otherwise, I have solved something incorrectly before and gotten 3 points, one of them out of the line, wasn't on the line at all, and I went back and started over because I knew I'd messed something up. Let's take a look and do it like this. So I'm going to put a little graph here. I'm going to say if x is this, then what is y? And you can pick anything for x, or you can pick a value for x, or you can pick a value for y. Depends on your equation up here, and you want to make it easy on yourself. Now this one's tough. Why it's tough is because x and y are both on the same side of the equation. I would prefer that not be the case. I'm going to take this negative x and I'm going to put it on the other side. In other words, I'm going to add 3x to both sides, right? If I add 3x here and I add 3x here, I'm going to stop making all these notes because you guys are getting it by now. What I get is y is equal to 3x and a positive 2. This is easier for me to do point plotting because it makes the math that I've got to do easier. And you always want to do the easier math. So what can I put in? What value do I put in? Well, always choose the complicated side. Y is already solved for y, so let's pick a value for x. Let's choose x of 0. That's always a good thing to start with. If x is 0, then what I have is y is equal to 3 times 0 plus 2. 3 times 0 is just 0. So what is y? Y is 2. So I have 1 point on my equation, okay? 1 point is already set up for me on my line. Let's do another one. Let's just make the math easy. What I want to choose for x, because it's the complicated side, I'm going to say, let's make x equal 1. Okay, this means y would equal 3 times 1, well that's 3, plus 2, or 5, right? And now always choose a negative. It's always a good idea to choose a negative as well as a positive. Why don't we choose negative 1 for x? So this means that y is equal to 3 times negative 1. Well, that's negative 3 plus 2. Negative 3 plus 2 is negative 1. Now I have 3 points. If I graph those 3 points and they make a straight line, I'm good. I've probably done it right. Let's try it. I've got 0, 2. I don't move anywhere on the x-axis, but I go to a positive 2 on the y. That would be 0.02. For the next point, 1, 5, I go in the x-axis, I go over 1, and then I go up for a positive 5 for y. So there's my 1, 5. And the next point, I'm going to go negative for both. I'm going to go negative x is negative 1, negative y is a negative 1. Here's my negative 1, negative 1. And then I need a straight something, and you can use anything. I'm going to use an iTunes gift card that I always seem to have lying around. And yep, they do look like they make a straight line. Now this line, just keep in mind, never ends. It goes on and on forever, right? Straight line looks like a good linear equation. I graphed it with something called point plotting. You fix the equation so that you make your math as easy as possible, and you insert a value for the complicated side, the side that is not already solved for. And it's really easy usually to do the math for that. So let's take a look at example 2b. Now 2b says, is it linear or not? Now remember my rules for linear. It can have an x value, x coordinate, and it can have a y, and it can have a number term, but it can't have anything like a squared, x squared, or absolute value of x. I know when I look at this one that it is not going to graph as a straight line. So I'm going to go ahead and say this one is not linear. It has an absolute value of x. But we can go ahead, now we're not going to do a lot of work with these until your next course, okay? But we're going to kind of look at a couple of them just so you have examples to go by. Now, we're going to insert a value for x, and a good value to start with is always 0. Why x? Because it's over here on the side that's not solved for. The complicated side is the x side. Hang on a second, I'm going to make sure your video is working right. Okay, so if I have 0 for x, what is my equation? Well, y is equal to 0 plus 2, right? So it would be 2. Now let's put a positive value in for x. Let's try 1. Then y is equal to, what's the absolute value of 1? Well, it's just 1 plus 2. That would be 3, right? And now let's do the negative x. Let's say x negative 1. Well, this time y is equal to, now what's the absolute value of negative 1? Well, it's still just positive 1, isn't it? Doesn't absolute value just take away the negative? It turns everything positive, right? So this is going to be another 3. This is why it's not a straight line. It's because that absolute value is going to make this thing turn. I've got 0, 2. No, I don't move on the x-axis at all, but I go to a positive 2 on the y. That's 0.02. And then I've got 1, 3. X positive 1, y positive 3. And then I've got a negative 1, 3. So I go x negative 1, y positive 3. And I can tell that it is not linear. Now, I believe, because I happen to know, that this one does this, right? So it's not a linear equation. It's not a straight line. We knew that, though, when we looked at it because it didn't have all simple arithmetic operation procedures in it. It had an absolute value sign. I think I've got one more page for you, one more example that we're going to go over. And this one is going to take us through another example of something that has, this time it's an x squared. It has x squared. I know it is not linear. So what is it? Well, we'll look at it this way. We'll do some point plotting for this one. We'll pick a value for x. Once again, I'm going to choose 0. I have y is equal to 0 squared, which is 0 squared minus 4. Well, that's just 0 minus 4. Negative 4, right? And now I'm going to choose 1 for x. I feel like a broken record here, but 1 squared is 1 minus 4. It's going to be a negative 3. You could choose other numbers if you get bored with these, right? It doesn't matter. And then I'm going to say y is equal to, well, I'm going to choose a negative 1. A negative 1 squared. Remember, the negative 1 is the value of x, so you're squaring a negative. And what happens when you square a negative? Well, I get a positive 1 minus 4, don't I? It's going to be another negative 3. So here I've got a really same sort of situation, right? Same sort of situation. Let's look at it like this. I've got a 0, negative 4 for my first point. Here it is. I've got 1, negative 3. So I go positive 1, negative 3 is the y direction. 1, negative 3. I've got negative 1, negative 3. My points are really close together. And I know that my graph is going to turn up, okay? It's going to turn up one way or another. I'm going to just kind of graph it out here. All I have to do is prove it is not linear at all, is it? It's not a straight line. It does make lines, but it doesn't make straight lines. So there's a difference in linear equations and equations that are not linear. We're not going to really do any work with these, and you will in the next class start graphing them. You'll use a graphing calculator to start working with them and different kinds of unusual shapes. But for right now, it's good that you just recognize them and you recognize the equations that they are built from.